All right, this is 2-5. This is number 1 on 2-5. The biggest thing different here is whenever you've got the first layer difference and the second layer difference, what'd you notice on the second layer difference? Well, in fact, let's actually get there before we actually do that. So the difference here, what we got?
15.
15.
9.
9.
6.
6.
3. 4. And 7.
And 7. Okay, so again, we didn't really care about this layer right now. We're not focusing on it too much because this is not linear. It's going to be a quadratic, so we're going to be focusing on the second layer. So for the second layer, we should get the same number if it was a perfect quadratic, but keep going. What we got? 15.
6.
Ooh, actually, these are wrong. These are wrong. Between 163 and 147, you do not go up 15.
Oh, it's negative.
Oh, okay, cool. So it is negative. That's his negative. I'm going down, I'm going down, I'm going down, I'm whoop.
You're going up.
Okay, that might make a big difference here on some of the stuff there. So watch out for that. So again, negative 15 to negative 9, I am going up, okay? I'm going up by 5, 6. And then here to here,
3.
I am going up, but I'm going up by 3. Here to here,
3.
3. Here to here, negative 3. I'm going across to 0 and then over to 4. So I'm going a total of 7, right? From negative 3 to 0 and then from 0 to 4, if you think of it like that. 7 total distance. And then here to here, 4, 5, 6, 7, 3. Okay, so is this a perfect quadratic?
No.
No. That's the whole point of these, and that's what we did last unit as well about the average. Okay, we gotta find the average second layer difference. We see 3 a lot, so it's gonna be a little more than 3, right? The 6 and the 7 are gonna inflate that a little bit. So how do I find the average of stuff? Again, we struggled with this.
You add them all together.
Add them all up. So I got 6, 7, 8, 9, 10, 11, 12,
22.
13, 14, 15, 15 plus 7, 22. Okay? And I divide by how many things that there were?
5.
5 things. All right, what is that? I have no idea.
That is 4.4.
4.4. So I got 4.4 is my average second difference. Okay. And I'm gonna jump in off this right here. What is my first difference?
It is negative 15.
My first difference is between 0 and 1 is negative 15. Okay, so I have negative 15. Right? I'm gonna keep it all organized right here. Check this out. And then my a sub 0. A sub 0. 163. Great. All right. So there is no difference here from what y'all have been doing for forever now of differences. Find the first layer difference, second layer difference, a sub 0. The only curveball here, and for the rest of this whole time, the only curveball here was it wasn't the same, which is the same thing that happened on the last test. So then we had to average it, and that's all. Okay. Nice. All right, now we do the same dang equations. Okay, they're not written up here, but you should have them in your notes, and you should have them in your notes. So what do we got for the A value for?
It's your second difference.
A is my second difference divided by 2, right? What is my second difference here? The 4.4, right? It's not going to be one of these numbers. It normally is the consistent number that's the same all the way through, but this time it wasn't there. We had to average it. This is my second difference, okay? All right, so we got it there. So then A equals 4.4 divided by 2 is 2.2. Cool, okay? The number one mistake I see people make is they feel like they've done a calculation and then they think this is A, right? Normally you have to do a calculation to find A, and then they just say it right here. So we did a calculation to find an average, and then a lot of people are like, oh yeah, 4.4, that's A. No. 4.4 is the average second layer difference that I have to divide by 2. So don't forget about that little step. You do the same step. Okay, so now I'm moving to the blue marker for B.
Isn't it like A minus?
First difference is negative 15. Okay, no big deal. It just happens to be a negative. We're going to have a negative number. Be careful. Minus A. A is 2.2. So then B equals, I have a negative 15 and another negative, so it's going to be even more negative. Negative 17.2. Okay, quick little tip here. Okay, a lot of people, negative numbers confuse people. In my head right now, I did 15 plus 2.2. You with me on that? Like in my head, or if I did this in the calculator, and you guys love using your phone calculators or regular calculators, whatever. If I did this in the calculator, I would have pressed the button 1.5 for 15, and I would have added 2.2, and I'd press enter, and I'd get this, right? Well, actually, I'd get this. But then what would my smart human brain know that I did with these numbers? Well, why did I add them? They're the same sign, is what I'm saying, right?
Yeah,
when the two numbers are both positives, you add them together, like you normally have done since 2nd grade. But if they're both negatives, in my head, they're both the same sign, they're both the same team, they're both the same kind of number, they're both negative, so I just add them together and then write down a negative number, right? What happens when they're opposite signs?
They're negatives. You subtract them.
I subtract them, and then I add the sign of the bigger one, but I don't want to confuse you. Okay, anyway. And then C.
A sub 0.
It's just A sub 0, so 163. Cool. So my final answer. Did I have my purple one? I like my purple final answer. Final answer is y equals ax squared. So I have 2.2x squared plus bx. But I had a question asked last period. It's plus bx because you just add on the bx. But in this case, it's a negative. So sure, I minus 17.2. Yeah, 17.2x
Plus 160.
plus 163. The same steps, the same simple steps, just with a few decimals in there, okay? So there's your answer. Now, it goes on to ask us one more question. Use your model to predict the average price in the year 2010, okay? 2 ways to do this. There's probably more ways, but two easy ways to do this. I could go to 6 and then do what? 10. I could keep going all the way to 10 and find it, and then extend the pattern all the way out. And if you're in the middle of a test and you hit a brain fart or whatever, then do that and just extend it out. It's going to take you longer, but that's probably that's going to be a super easy way to do it. And also, real quick, just to make sure you understand where the 10 came from, is it said find out what will happen in the year 2010, right? This is years since the year 2000, right? So it's been no years since the year 2000. What year are we in?
2020. Oh, we're just at 2000.
So this says years since the year 2000, and it's been 0 years since that has happened. What year are we in right now?
2000.
2000. 20 years didn't just randomly pass. I know what year it is now, so maybe that's why, I don't know. But anyway, 1 year has passed. Now we're in the year
2001.
Okay, you need to get obvious. Okay, so then now I'm looking for 10, which is where the 10 came from, right? Okay, just making sure we're on the same page. All right, so I'm looking for whenever x is 10. All right, instead of plugging in, or not plugging, instead of extending the table all the way out, what could I just do for x? Plug in a 10 right there, right? So I'm going to do this live with an expo marker. I would write this again on your paper if you had it. But I'm going to plug in a 10. I'm going to plug in a 10, okay? Put it in parentheses, all that good stuff. So I'm plugging it in, right? So right here, PEMDAS, remember PEMDAS, order parentheses, right? Parentheses, exponents. So what am I going to have to do here first? Parentheses, okay, but inside the parentheses, is there any operations happening inside the parentheses?
Yeah.
No, there's just a 10. Right, so as far as how to read PEMDAS, you see parentheses, and I know there are parentheses, but is there anything happening? Is there any action going on inside of them?
No.
No, there's just a 10 sitting there as a 10, right? So parentheses are done. What's next? PEMDAS. Exponents. Okay, so let's take care of that. There's only one. Who's being squared? Is he being squared?
No, the 10's being
Just
squared.
the 10. So 10 squared, right? So I'd have 2.2 times now, this is 100. Minus 17.2 times 10 plus 163. Okay. This might be annoying to keep writing in multiple times. Once you get good at this, you can skip steps and do things all at once. Because what I would have done just now is do 100 times this, right? So that's just going to be move the decimal place over twice. That's 220. Or you can put it in a calculator, 2.2 times 100. Or if you know the little decimal moving trick, right? Yeah, okay, oh well. And then this is times 10 though, so I'm going to minus, I move the decimal place here, so I got 172. Again, if you don't know what I'm talking about, just do 17.2 times 10 in your calculator. but you can just move decimal places every zero, but that ship has sailed. All right, plus 163, nothing's going on there. Then you just add that all up together and you're done, okay? The only thing that was difficult there is being careful about the exponent being squared, or the x squared variable, and also make sure you plug it into both x's, right? You got ax squared plus bx, make sure you plug into both of those x's, whatever number you're plugging in there. So what's the final answer?
211.
211, got it. So we have 211 is the average sale amount
In
of money.
2010.
And that's all. What?